Okay, let's try and solve some more examples on dimensional analysis problems together. Before I do start that, I want to emphasize the importance of practice, the importance of you solving as many problems of these kinds as possible. There are many examples at the end of chapters in this textbook that we are following. There is also a worksheet posted on Canvas. I am expecting you to be solving all of those as well. It is not enough to just go through these 7 or 8 examples that we have in the lecture slides. We do need to solve the others as well. Okay, so here's a problem where we need to convert 6.750 times 10 raised to 4 centimeters to miles. So how do we do that? Now, there are often almost all the time there are more than one way of solving a problem. There is generally more than one path to solve a problem, and they're all correct. Of course, I can't show you all the possible ones, so I will show you one. That does not mean that if you used a different method you are wrong. No matter which method you use, the answers should be very, very close to each other because it's the same problem. Okay, so here's an example where we need to convert centimeters to miles. So we could either go from centimeters to meters to kilometers to miles. We can definitely do that. We could also convert centimeters to meters to inches to feet to miles. You can take any of those paths as long as you know what are the individual equality equations that are relating the units that you are converting between. You can of course find a very comprehensive list of these kind of equations on the internet. There are of course some examples in your textbooks, chapter 3 as well. So don't hesitate to do a Google search for an equation if you want to go from a certain unit to another. Okay, so let's use this path as an example to solve the problem. We know that 1 centimeter equals 10 raised to minus 2 meters. We also know that 10 raised to 3 meters equals 1 kilometer. And we know that 1.609 kilometers equal 1 mile. So we do have the standard equations needed for this path. Okay, so let's set it up. As I said before, that we must always start with the measurement that needs to be converted. In this case, that would be 6.750 times 10 raised to 4 centimeters. We need to convert centimeters first to meters. So centimeters goes at the denominator because that allows us to cross those out, and meters goes on the numerator. In the second conversion factor, now we want to get rid of meters, so that goes in the denominator, so you can cross it out and it gets converted to kilometers. And then finally for the next conversion factors, kilometer crosses out, leaving behind the unit miles in the numerator, and that's what we need. Now, as I said before, I think taking care of the units is extremely important. That's what I do. When I solve these problems, I first put my conversion factors properly so that I have units placed properly to end up with the unit that the question is asking for. Once you do have the units in place, now you're ready to put the numbers in the conversion factor. So according to this equation, we know 1 centimeter equals 10 raised to minus 2 meters. According to the second equation, we know that 1 kilometer equals 1,000 meters. And based on the third equation, we know 1 mile equals 1.609 kilometers. So when you look at the setup, the units, all the unwanted units are crossed out, leaving behind only the unit we need. Now we are ready to calculate this. If you are not sure how to calculate a problem such as this, please understand that everything that is on the top gets multiplied by each other, and that product is then divided by everything that's on the bottom. So a way to look at it would be 6.750 times 10 raised to 4 times 10 raised to minus 2 times 1 in the numerator. If you're using a graphic calculator, you would need to use parentheses appropriately in order to get the correct answer, divided by 1 times 10 raised to 3 times 1.609. The unit that's left over is miles. When you calculate this, the calculator answer comes out to be 0.419515 miles. Is this our final answer? No, it isn't. We do have to represent the final answer in correct number of significant figures. So how many significant figures do you think this answer should be given in? Absolutely, 4. 4 significant figures based on the coefficient of the measurement given. So that means we need to round this number right there, and that gets rounded to 0.4195 miles. That will be the final answer in 4 significant figures. Okay, let's try out the next one. This time we are being asked to convert centimeter cube to inch cube. Now you have to be very careful when you're dealing with units that have a power such as centimeter cube and inch cube and so on and so forth. What does that mean? What does centimeter cube mean? It means it is centimeter times centimeter times centimeter. Similarly, inch cube means it is inch times inch times inch. So we do have to keep that in mind. It is very important to not lose track of that. Okay, so now let's set it up. We do know that 1 inch equals 2.540 centimeter. Now, if I wanted to convert this into inch cube and centimeter cube, you have to be very careful. Okay, so let's set it up to illustrate what I really am trying to tell you here. So we start once again with the measurement that needs to be converted, 6.750 centimeter cube. Now I'm going to write centimeter as centimeter cube as centimeter times centimeter times centimeter to illustrate the point that I'm trying to make here. Okay, so if I use this standard equality to create a conversion factor, I hope you see that centimeter goes on the denominator, inch goes on the top. 1 inch equals 2.540 centimeters. But when we do use this conversion factor, how many centimeters are we able to cross out? I'm only able to cross out 1, not all 3. What do I need to do in order to be able to cross out all the 3 centimeter cubes, all the 3 centimeters multiplied by each other, and end up with inch times inch times inch? You're right, absolutely. I will need to use the same conversion factor 3 times. Because when you do that, then you see that all the centimeters are crossing out, they're canceling each other, and you end up with inch times inch times inch, which is nothing but inch cube. Using the same equation, 1 inch equals 2.540 centimeters and 1 inch equals 2.540 centimeters. Basically what I'm trying to say is that if you needed inch cube to convert into centimeter cube or vice versa, you not only cube the unit, but you must also cube the numbers in that equation. See, we've got 1 times 1 times 1 in the numerator, we've got 2.540 times 2.540 times 2.540 in the denominator. So whenever you're using a standard equation in this manner, whatever operation you're doing to the units, you must also do that to the numbers. Okay, so now when you've set up this equation, yes, the answer will be in inch cube, and the calculator answer comes out to be point 0.411910273 units now are inch cube. How many significant figures must this answer be given in? You go back to the original data. The original data is in 4 significant figures, so you must round this to 4 significant figures as well. The final answer, therefore, is 0.4119 inch cube in 4 significant figures. Can you write this answer as a scientific notation? Absolutely. There is no harm in doing, there is no reason why you can't. Whether you represent the answer as a decimal notation or scientific notation does not matter. There is no one correct way. Both of them are correct options. Okay. So let's go on to our next problem. This time we are converting a speed in kilometers per hour to another speed in miles per second. Now please let's take a minute and understand what does kilometer or any unit such as kilometer per hour really mean. It means that there are so many kilometers traveled in 1 hour. So from now on, for the purpose of solving these problems, I'm going to ask you to write these units as having a numerator and a denominator very clearly so that you know how to place your conversion factors. In this problem, we need to do 2 conversions. One of the conversions is to go from kilometers to miles. And we know that 1 mile equals 1.609 kilometers. Excuse me, something. But the other conversion that you also have to carry out in this case is to go from hours to seconds. We can go from hours to minutes, and we can go from minutes to seconds. Can you go directly from hours to seconds? Absolutely you can. If you combine those 2 equations, you would know that 1 hour equals 3,600 seconds. And yes, you can definitely do that as well. Okay, so let's set it up. As I said before, we start with what's given that needs to be converted. 89.5 kilometers per hour needs to first, let's take care of the kilometers first. Kilometers will go on the denominator, miles on the top, so that kilometers cross out. At this time we have the units of miles per hour. Now we need to convert hour into seconds. So hour will have to be on the numerator because only then can you cross those 2 out, and minutes in the denominator. And then of course minutes cross out by putting the minutes and the numerator for the third conversion factor, and seconds at the bottom. Please note that when you do that, what is the unit that you're left with? You're left with miles in the numerator and seconds in the denominator, which is nothing but miles per seconds. And that's what we need. So be very careful of the units. Units is half the battle. Okay, so let's go ahead and plug in all the other numbers here. So we know 1 mile equals 1.609 kilometers. We also know that 1 hour equals 60 minutes and that 1 minute equals 60 seconds. When you are calculating this, once again, use parentheses very carefully. If you're using a graphic calculator, all the numbers on the numerator get multiplied by each other and get divided by the product of all the numbers in the denominator. And the units at this time are miles per second. When you solve this in the calculator, we get 0.015451281 miles per second. This answer needs to be represented in 3 significant figures based on the information given, which means we need to round it right there. It gets rounded to 0.0155 miles per second. You can of course also write this number in scientific notation as long as it's in 3 significant figures. That would be 1.55 times 10 raised to minus 2 miles per second. Either option is correct as long as we have the answer in 3 significant figures.